Well, good afternoon to everybody. My name is Greg Giroux, and to my right, Eric Chevali, and welcome. This is our breakout session to talk about Metroplex toss departures. And we're fortunate we've got Joe Friend up in the front, and I see Josh and Darren back here from Southwest that have also very important pieces of this because they're our field partners. So as we have questions and we kind of work our way through this, they can certainly help us answer those as well. I think Eric and I would like to keep this as informal as possible. So if you want to, kind of old school, if you want to stop and ask a question as we're going through stuff, then please feel free to do that. We want it to be interactive. So we'll probably just go over just a couple slides from this morning. And the main focus that the main item we're going to put our focus on today is actually a live demonstration of the system, which I think will open it up to some more questions and ideas. So. So just as a brief review, I know we covered this morning. This is the basic idea behind utilizing TOS in the Dallas-Fort Worth Metroplex. The first slide here is basically the problem. That particular slide shows 4 routes to the east, which is the norm. It's what exists, but as soon as you have an area of weather that builds up, such as this, those routes are reduced. Could go from 4 to 3 to 2, sometimes 1, and obviously that impacts the demand. Your capacity is reduced from 4 routes to 1. One thing that is notable about those routes, by the way, is they're very, relatively speaking, they're very close together. They're about 5 3/4 to sometimes 6.5 miles apart. If you're not familiar with the separation that our en route ATC folks they need 5 miles. So that hopefully gives you an idea if weather builds and aircraft begin to deviate, one or more of those routes are going to close pretty quick. So it provides a tremendous amount of capacity with good weather, but because they're so close together, that's going to cause a reduction. And then as we covered this morning, the slide to my far left indicates the opportunity to, if we do have capacity issues or delay issues on the ground, that to try to utilize some opportunities to depart at a different departure gate. And then real quick, again, because we covered this morning, the before day of really means the development of the tool, particularly CDRs that already existed. And the utilization of those, it lets everybody know, airline and ATC, what sort of routes are going to be available as those alternate routes. The key to it all, of course, is the Predictive Engine. If you think about what ATD-2 really does, is it predicts the time an aircraft's going to depart. And if those projections, I'll call them projections, if those projections are not accurate, it really makes everything else not function as any of us would want it to function, because we're not, as we present to a airline operator, hey, this flight's a candidate for a TOS, it's all based on what the projected departure time is, which means that's also what the projected delay is. So if that's not accurate, if we're projecting a 20-minute delay and it meets the airline's criteria to fly the additional miles, but in reality the delay they're going to take is only going to be 6 or 7 minutes, then we've kind of defeated the purpose. So that's a real key to the system. As Eric showed this morning, this is what we call the TOS table. That's how the candidate flights are presented to the operator. Again, it's based on their own criteria that they've provided to us. The system calculates it based on measuring projected surface delay versus additional flying miles, and it says hey Southwest or hey American, this one meets your criteria, therefore it's a candidate flight. Actually, if you're wondering on the day of, during actual use, ATC does not really become directly involved until step 4. They're aware of the process, they're aware that TOS capability exists, but in terms of any actual rerouting of a flight, there's no ATC involvement until we get to step 4, which is after the, in our case, American or Southwest has actually submitted a flight. And of course, a big part of this entire process is the post-ops evaluation, which lots of data, lots of assessing how are we doing and what benefits are we gaining. All right, now we're going to start with a demonstration of the system. We're actually using live data, and Eric and I are going to kind of tag team this and kind of talk to you a little bit about the different components of the system, what they do, and what they tell us. I'm going to cover the first two. The one to our left here is what is called a timeline. And basically there's a lot of capabilities within that timeline on how you set it up. This particular one right now is set up with DFW departure traffic. On the left side is the DFW departure traffic off the west runway. On the right side, the DFW departure traffic on the east runway. This is the current time. I know you can't really see that. And then these are the projected times for the aircraft to depart. And that's based on a large amount of data, including earliest off block time. And that's why at least I think in all of our views that are using it, the earliest off block time element is such an important piece, because all of us, airline or ATC, have long had equipment that tells us, hey, I want to know how many departures are projected in the next 15 minutes. Well, we could use TFMS for that, but keep in mind that's a scheduled departure time. And scheduled departure times, airplanes don't always depart on their scheduled departure time. That's why the earliest off block time is such an important piece to it. Lots of flexibility with the system. Again, as you look at this timeline, the aircraft are actually colored by departure gate. And they could be colored in a different way, but I think I know Joe's here from DFW Tower, they find it very useful just to kind of take a quick glance. Love Tower does the same thing and say, well, you know, it looks like I'm going to have a heavy departure demand to the east gate or the north gate or whatever the departure gate happens to be, just based on color. I think that's it on the timeline before we get, and then the part in the top center, that's what we call our map. And I'm going to demonstrate one thing to you here real quick. But that basically shows the TRACON airspace. It shows the departure fixes, the field users, and when I say field users, that can be airline or ATC can select. I want to look at Dallas Love departures, Dallas Love arrivals, or both. I want to look at DFW arrivals, DFW departures, or both. So there's a lot of flexibility there, and I think if you were to talk to the individual users, you would find that they have different uses and different ways or different things that they really want to look at. So the map, both of these, the timeline and the map, even beyond the TOS, which when we get to Eric's part, we're going to get to the actual TOS part, but there are a lot of uses of those two tools, as we talked about this morning in the panel, for situational awareness. I'm going to point out something to you real quick. You see north, east, south, and west. There's 4 departure fixes in each gate. I'll just do the south one because it's easier to reach. See 1, 2, 3, 4. And then I'm going to give you a quick example of how quick the situational awareness becomes. I'm going to put in a couple restrictions here. So what I'm going to do is put in a couple quick restrictions to the south departure gate.
So what Greg is doing now is doing a manual entry. But as we briefly talked this morning, one of the effort with this phase 3 was to develop standardized NTML entries. And so we work with the en route TMCs to come up with entries that would actually make it to TFM flow data. And part of the ability to parse these restrictions is that they are entered consistently. So we worked out some standard so that it could be entered always the same way, so we could recognize what those restrictions mean. And so we have a TMI service as part of the phase 3 that parses these restrictions and then automatically populate the clients. But there may be instances where the system is down, or there are reasons to modify restrictions, so the user always have the option to make a manual entry, and that's what Greg just did, so that we could demonstrate what happens when there are restrictions in the system.
And just to tag along with what Eric just said too, one of our main goals as we were preparing to do this was to put the least amount of additional work on our ATC field partners, because they already, if you think about it, a lot of this occurs during a convective weather, a highly busy, highly active time for them. They already are making other entries to show these restrictions, and the last thing we wanted is, okay, hey, by the way, in order for our system to work, we need you to do what you already do, and now make an additional entry when it's a highly active time. So what I did, and again, as Eric said, normally these do not have to be made manually, but we did them today for demonstration. Remember, I showed you the south departure gate with all 4 routes. You'll notice one of them is grayed out. That one was closed by the entry that I made. And then you'll notice there's a 20 miles there, meaning one of the other restrictions is 20 miles in trail over that particular fix. So it immediately shows up on the map. All of our field users see it. If you're an airline, you're looking at it and you're thinking, okay, there's going to be potential for delays there, certainly. We know exactly what the restriction is. And this is actually information that very likely prior to ATD-2 they would not know. Now they would have some sense that there were delays in the system, or maybe traffic was backing up in the surface, but I don't know that they always knew exactly what that restriction was. And as soon as it's entered into our system, as you can see, it comes up. It also shows up on the timeline. And again, I know this is very hard for you to see, but this is the particular route that we put the 20 miles in trail on. And you can see the 20 miles in trail there. And it immediately tells them there's a restriction on that particular flight going over that particular route. You'll also see, and I won't demonstrate it here in terms of time, but if you have aircraft that are pretty much 1 minute apart here, they're going to depart, let's say you put a restriction in on those routes, something like 20 miles in trail, they're going to spread out because our system knows they're at 20 miles in trail, they're not going to depart or be able to depart 1 minute apart anymore. It's going to be 3.5 minutes apart or 4, whatever equates to 20 miles in trail. So immediately, and I think Eric's going to put in a couple real quick restrictions for us. Well, while he's doing that, let me just stop for a minute. Questions so far? Anything that we've said so far? Yes, sir.
On the map, on the slide you talked about how, let's say that the east routes are closed, and you were going to swap departure routes. On the color coding would be, and you were going to run them out of, say, the eastmost, west, and north. Would those change color to whatever the east gates would have normally been? So that instead of being blue along the bottom, that there would be color coded on the eastmost gate, it would be yellow, just to kind of indicate that we're running what normally would have been east traffic out of those gates.
Not on the map. On the timeline, when a route is combined, it doesn't necessarily change color. And again, I know this is really hard to see, but it shows the original fix that fix is now closed, and the fix that is open, that route is being moved to, if that makes any sense, okay? But in the case that because in this case, and Eric was kind enough to enter some east gate restrictions in the yellow, even though there's only one of the 4 routes open, it's still an east gate route, so it would stay in yellow. I hope that answered your question. So, other questions so far? Yes?
Hey, Greg, so when you change that to closed or mountain trail, do you put in a time frame? That's going to be 90 minutes or?
You can on this. In reality, what really happens, as Eric described earlier, is it's being done through the MTML by Fort Worth Center. And what they're normally doing, Mike, is about a 2-hour in time, because they really don't know. Their concern, number one, is guessing, what's the weather going to do. And then we talked, as we met as field users, with American and Southwest, we talked about, in the Towers Center and Tracon, well, what if they put 45 minutes? And one of the concerns the center has is, we're busy, as you are, at the desk. What if we forget? And the restriction's still there, and we're doing other things, and now it cancels automatically because it's 45 minutes later, but in reality, the restriction's still in place. So for the field tests that we've done so far, they've been using 2 hours.
And so does that, when you put in that restriction, does that trigger on the page with all the flights listed as what's a candidate? Will that trigger that, or do you have to manually put something else in besides that?
No, it'll show candidates during that time frame, if there are candidates, right?
But it'll pick up that's now closed, therefore these are not.
Yes, yes. And on the timeline, I don't know if we can do this or not, Eric, but well, we manually entered it without a time, but let's say it had an end time. If there was a flight that was projected to depart beyond that end time, it wouldn't even show that restriction, okay?
Yeah, I was going to say the restriction is an input into the scheduler, and so the start and end time is definitely something that the scheduler takes into account. And then given the predicted off time, it looks at whether it would fall inside that restriction period. That's what the scheduler does.
It'll do the very similar thing for runway closures too, Mike. If you put a start time and end time, it's going to project that no aircraft are going to depart the runway when it's closed, but if we say, hey, that closure is going to end at 1500, it'll start saying, at 1505, there are going to be airplanes departing that runway again. Yes, sir. See somebody? Yes, sir.
Yeah, in the case of a stop departure fix, is there a process within ATD-2 to manage that, the process of having a Pathfinder flight?
No. I mean, Pathfinders are still used, I know, by ATC, but...
I know if there was some way to designate that in the system.
I don't believe there is in ATD-2. I think there still is in TFMS, if I'm not mistaken, or there used to be. I used to work for the FAA, I don't anymore, but there used to be a way to do it. I can say in the North Texas area, it's usually just coordinated verbally, because they run a hotline, and it's just so much faster for American or Southwest to say, hey, we have Southwest 123 willing to, the East Gate's been closed a while, but it looks like it's getting better, but everybody's a little uncertain. And one of the airlines may very well say, hey, we've got a flight that'll try it, and that becomes a Pathfinder. So, other questions about timeline or map at all? All right, I'm going to turn over to Eric.
Yep. So let's look at what is happening on the airline operator side. And so another component that is tied to the timeline is the graph. And so it takes after FMS. So we have the the undelayed time and then the scheduled time, and then you can use the graph. It can be tailored reference to the runway or fix or gate or anything you want. And you can change the time bins, and you can look at only scheduled time or undelayed time. And the example you see in the upper right corner is undelayed time and then scheduled time. And because of the restriction, you can see in the first bin that there can only be so many departures the parties in the first bin, and so you immediately see that you have excess demand, and this demand is propagated into the future. So that's the graph, and we have also a delay graph. And so I'll talk about the toss table. So you saw the restrictions, and so right now in DFW, with the given demand, we have this toss table, and we have it filtered so it would show any flight that have at least one route as a candidate. We have another bin that would list all the flights that have at least one route that has been submitted, and then another one where it shows whether ATC has approved or the reroute has been filed. And our system is able to detect if the flight plan has changed on this flight, and I would finalize the process of rerouting. So right now there are four aircraft, 5, that are bound to the east gate. You see the route there, the OBT, their estimated takeoff time. You see the estimate for alternative route. You can see, maybe you can see there, but I can tell you there are between 10 and 30 minutes of delay savings for these flights. You see the flight states, whether it's still at the gate or has it pushed, is it in the ramp, is it taxiing. We've also showing the TMI information, so you can look at specific flight and see what they're subject to, if they have an APREC or edict or terminal restrictions. We have what we call toss states, so we have an eligibility states that indicate whether the flight has at least one route that is candidate, or in a normal state is called potential. We also have exclusions there, and we can talk about that later if we have time. And then the coordination state, which reflect the process of coordination between the flight operator and ATC. And default is not submitted. When the operator submits a route, it changed to submitted, and then ATC approved. And I'm gonna demonstrate that right now. So for each flight, you can bring up the toss route. So here I have it sorted by EOBT. So which is the first one is the first flight that is predicted to push. So this may be the flight you may be first interested to determine whether you want to file a reroute. So for each flight, we have a right-click menu where you can submit routes, but you can also look at the actual toss for that flight. And that's what this table is. And here, each row is a route. And the first row is the flight plan, and the following rows are the actual CDRs. And you can see for that flight, there is a route to the north, to the south, and another one to the north. We're showing the distance on these routes, our best prediction, the best estimate of the distance, the difference of mileage, and then the relative trajectory cost. And the delay for each of these routes, the estimated takeoff time. And you can investigate what your choices are. So for this flight, there is, in this case, the 2 routes to the north have enough delay savings that exceeds the relative trajectory cost for this alternate route. So in this case, the operator can investigate whether they want to go through Nashville or Roseville to the north. So the dispatch there ATC coordinator will look at the wind routes and the situation from Dallas to the destination there, and decide which route is most appropriate to submit based on the fuel on board. So you can submit from this toss table, or you can also right-click here and go submit, and once you know which route you want to submit, you can submit it. You can also say, hey, I think I'm fine with either routes to the north. So I'm going to submit these 2 routes. I'm demonstrating the capability, though I have to say in the field test, we've never been in a situation where the operator submitted more than 1 route. But it's possible. So, so that's what happens on, yep.
So in this case, what would the system do if you inadvertently submitted what you did, but he was subject to an edict, like he is on that point?
Yes. So, that's one of the lessons learned. So there's several aspects. This is a loaded question. Thank you, Tim. So generally speaking, we realized, in this first evaluation, we decided to exclude the edict and APREC flights because effectively rerouting flights to a longer route changed the arrival time and possibly when they would cross FCAs. And so that means we would need to reschedule an edict or takeoff time. So for this reason, we've decided to exclude these edict flights. It doesn't mean it wouldn't be possible to reschedule them, but it's a lot more complicated process. And so what we've done in this field test is if your flight has an edict, it would show up in the TMI information, and what we did was simply ignore those flights.
But I think, Tim, is what you're asking is like, let's say, maybe I misunderstood, but I think what you're asking is, let's say you submitted it, even though it has EDCT, and we approved it. I think your question is, would it move the departure time
Yeah,
up?
I mean, today
Yeah.
we do filter those, but let's say for whatever reason we did
Right.
it, and we inadvertently submitted this, not realizing it was subject to an edict.
And then we approved it, or
Yeah.
ATC approved it, excuse me.
Or would it catch
Right.
it?
I don't think it would.
Well, I mean, we just agreed procedurally to not approve a reroute for edict, so
Right.
it
So I
would
think
fall
it
on.
would move the time up,
Yeah.
even though technically we can't do that per se.
Yeah.
So if you submitted it by accident, how do you reverse it? You guys just don't approve it.
Right.
Well,
Change.
The
There-
tower would probably look at it and say,
Yeah.
you know, I can't do that. I have a controlled departure time. We're working, we already have the capability. We've learned pretty quickly that TMIs beyond the TRACON center boundary are a big factor. We thought they would be, and they are. And
Yeah.
of course, we tested, the time we ended up testing is the real high activity time in the Northeast. So there's lots of TMIs in late July and August, as I'm sure you know. But already the individual user can filter those out. So like if I'm at American or Southwest, I can say, I don't want to see EDCT flights. And then they wouldn't become a candidate. Longer term, we're looking to, we're building actually a filter for Fort Worth Center. We feel like the center, because of the connectivity with playbooks and things like that, they're in the best position, and they will just take, you know, on a particular day, if they know we can't take those north CDRs because there's weather in Kansas City Center's airspace, they'll just, you know, make a selection on the box, and then the folks at American and Southwest would never even see those as candidates in that case. It would be a filtering, but without relying on the individual user per se to do it.
So I'll piggyback on what you said. So we're in one of the lessons learned here is to manage exclusions, and so you just talked about the global exclusions. The idea there is to have a window, an advisory where you would see which routes are available or not available, which destinations are available or not available for reroute. These are the global exclusions, and then another one is a single flight exclusion. So what we plan to have is a right-click function like this, where maybe the flight operator knows there is some maintenance issue on this flight, and so they will decide to remove this flight from the mental model of, you know, and reduce the list to, and I'll quote Tim, to have only relevant list of flights that could be really rerouted. So the global filter would take those that are not really relevant away, and then a flight operator can on their own, you know, cherry pick or exclude these flights. And just to respond to the submission, you know, if the user changed their mind or if they made an error, they realize, oops, this flight has an edict, I shouldn't submit a route, they can always unsubmit, just like here. You can go your mind at any time until the ATC approves. Now, once the ATC approves, you have to coordinate that verbally with the ATC.
And that's for a specific reason. Obviously, ATC wouldn't want, submit it and then they approve it. They start, because as soon as they approve it, at least as quickly as they can get to it, they're going to start revising or modifying the flight plan. And you don't want to be doing that and then have somebody with the capability that can say, oh, never, not that they'd be doing it arbitrarily, but just unsubmit. Well, wait a minute, we just modified the flight plan to go the other route. So that's why the unsubmittal is tied to prior to ATC approving it too. I think do we have another question? Yeah.
Yeah, just one more clarification on this. Even absent ATD-2, if we have a flight that's in a ground delay program, you will be rerouted. So I kind of wonder, the mantra of do no harm, we're really not doing any more harm than would be normally be done in this same situation without ATD-2. Am I making that clear?
I didn't quite follow it. I'm sorry.
So currently, if we're in this situation right now without ATD-2, if a flight is, if its departure fix is closed and we're going to therefore with a ground delay program, we will issue CDRs and they'll be given that CDR regardless of the effect it has on the arrival airport.
Okay, I understand. That's true, but remember, this is built based on the two airlines providing us information for their, take the EDCT part out of it to say it's now worth it for me as an airline to take the longer route because we're projecting the surface delay. It's true about EDCT flights, but this is built for way more than just EDCT related flights.
And there's some subtle complication with the edict. You could think, well, if the flight is no longer going through the restricted areas where they have FCAs, well, they could be exempt, right? But it turns out that actually all flights that are in the program have an edict, whether they need to be delayed or not. And so it adds complication to the rescheduling.
I guess my only concern would be we don't want to take it off the table as getting a reroute because it doesn't fit the rules of ATD-2.
Right, and again, I'm still absorbing. In that case, if there's a fix closed, ATC is going to reroute the airplane without the airline even submitting. You know what I mean? If the route's closed and they're going to LaGuardia with an EDCT and they can't go that route, then ATC is already going to be taking action. In the North Texas area, they would call it a swap.
What you're saying, so in the absence of toss,
Right. Right, because in today's environment, if all of those fixes, the example that we put up there to the east, and I know, again, it's probably hard for you to see, 3 of the fixes are closed, you see the gray, and there's the one. Let's say that whole east gate is closed because of weather, which does happen as the weather builds, and they're swapping those flights, that's what they call it locally, north or south or both, then those flights don't really become... from a feasibility, the last thing that ATC wants the airlines to do is submit those flights to go north because ATC is already rerouting them to the north. So TOS per se doesn't fit that weather scenario exactly. Yes, sir.
So actually, I was going to ask you that question. Do you see this down the road replacing swap the way we do it now? I mean, if we're swapping north, do you anticipate closing the fixes and letting the tool kick out those north CDRs and TFC have to do it manually?
Maybe if it gets to the point where it's done automatically, you submit and the flight plan goes through, then I could see that. I don't know if we'll ever get to that point. As long as we still have ATC folks having to reroute it, it's counterproductive for ATC to be already rerouting and the airline saying, hey, I want to go that way, that ATC is already rerouting the airplane to anyway. But down, would that be a great concept? Yes, I think it would be. Yes?
But during swap, when there's a swap statement and the airlines know that ATC is rerouting everybody, then they're fueling for that. They're fueling arbitrarily because they might reroute.
Right.
Where this would be, they're saying,
And this gives
Yeah.
them the capability to make that choice, like Tim or Darren and the Southwest or American folks, they would never.
Replacing the swap statement, right?
I don't,
The airlines would just arbitrarily load more fuel on if they know they have free option.
right, but the swap statement is different than actual swapping. The swap statement is just an advisory that, hey, there's gonna be weather building in the area.
Yeah,
There's
that's
a- yeah.
advisory, so the airlines pump more gas.
Right.
I think it comes down to the level of restriction and the capacity you have in the air, right? So you may be in a situation where you have to have traffic being rerouted. There is no real option.
And to carry the swap thing just a little bit farther, so to back to your question a little bit, where the swap might come into effect is, let's say all the east traffic is being moved north and they're swapping. Well, what you might see this system does have the capability to do is, let's say there's a true northbound flight, but now it's going to get quite a surface and terminal delay because it's competing with a lot more traffic because it's going north. Our system might say, you know what, if you go west today, you're going to reduce that surface and that terminal constraint delay. That's kind of how it dominoes from gate to gate. So.
And I'll just point out, you see the spacing between the east departures. There's a lot of, quote, unused capacity here. And so if you were to fly south or north, you may end up to take an earlier slot. So I'll just demonstrate the approval here. So you can approve from the timeline. So you see this T here that indicates that this flight has at least one route that has been submitted. But you can, as the ATC, of course, you can also have a list of the flight that have been submitted, and you can simply right-click. As I said, right-click, and then approve the route like this. So what our system will do will assume now this flight is expected to fly this other route, so it will change the route, it will update the demand in the scheduler. That is before the route is actually amended. So, and that allows the ATC to approve multiple routes and see immediately the effect of offloading and allocating these departures.
The other thing it'll do in that case is it, even though ATC's not filed the new or modified the flight plan yet, because the system is saying, hey, they approved it, it'll move all the other flights behind it up a slot or moving them earlier because it's saying, hey, that flight that was going east is not going east anymore. It's going in a different direction. So that moves every airplane behind it, both at both airports, DFW and Dallas Love. It moves whoever's next in the queue up in that slot. So and that's why it's done that way.
And just so,
In your example where east is shut off, everybody's going north, and then one of those north guys might get a reduced if they go west. How does that show up?
Well, it wouldn't show up on the map, but it would show up potentially in the toss table here, Joe. So let's say a good example is Denver. You know, sometimes airlines file west to go Denver, sometimes they file north. Well, let's say on a particular day they filed north, and now you've got all the east gate traffic going north, and now there's a lot more volume there, and it's not really that much farther to go west to Denver than it is north. In fact, I think it may be a little bit closer, but let's say they...
Where your cursor is, that all those flights would show up there?
Yes, that's what we call the toss table, right? Yeah. And it would show up, yeah, I'm trying to find where it says candidate. Well, we don't actually show, this one's showing potential now, but that's where it would show up. Yeah. Sorry.
yeah, no, it's okay. We can go back to, on the flight operator side, there are a lot more flights now that are candidate. I could repeat this process, but I think we wanted to cover maybe some of the lessons learned that we learned. We have about another 20 minutes. Okay. Yeah. So did you want to continue the global filtering, or should I show some slides?
Let's do the global filtering. One thing I was going to mention before we jump off the timeline also is one thing that DFW TRACON and Fort Worth Center have found to be very useful is you can configure these timelines just about any way that you want. So you can put Dallas Love and DFW traffic on the same timeline. If you want to pick a particular departure gate or departure fix, you can show what your demand is out that gate or out that fix, and both from a workload planning standpoint, both the Tracon and DFW Tracon and Fort Worth Center have found that to be a very valuable tool as well.
And just a nudge to our Southwest friends here. We also have 2 departures that are showing some delay savings. So do you want to continue to talk based on the system, or shall we switch? We switch. Yeah.
Yeah, you want to stop and see if there's any more questions before we do?
Yeah. Is there any more questions based on what we showed so far?
Yep, we got one in the back.
Yeah.
So that Denver westbound example, if there's not a cost system for that flight, will it show as a candidate?
So the simple answer is no. But what we have is we're not filtering CDRs beyond international flights. So we have all destinations in the U.S. and it just happens that there are CDRs to from Love Field and DFW. So as long as there is a CDR, then it is a potential route that the system will keep, comparing to the file route. Yeah. Okay, so we have a lot more content, but what I wanted to do here is these slides will be made available to you, and at the end we put our email address, and you can contact either of us with questions, comments, feedback. And so we have here next is for you to read before you go to bed, or not. And so we have the main components, some initial results, and we have some overview of our development for this summer and some lessons learned. And so we thought we could talk about some of the lessons learned, but we wanted to not necessarily make a call about what you're interested in. So is there one of these things that are listed here that pique your interest? Maybe I can say a few words about those. So we mentioned a few times we work with the en route, how to come up with standard entries that would make it into TFM flow so we could parse it. That's one thing we would like to share with the community. The other one is some modification in the scheduler and delay savings. That's way down in the deep, in the weeds. But if you're interested, we can go there. We also changed some the way we computed route distance. And then finally, I think the one that we would pick, that's something we would like to develop in the near future, is this global management, and we have some examples of playbook restrictions that we could talk about. So is there any topic of particular interest? Okay. Any other interest? No, we can go there, but I just want to assess.
That's the one we didn't want to do.
No,
So.
no, it's fine, it's fine. Okay. I actually would need to click on this link. Bobby, can you click on this one here? The scheduler delay savings. If not, I can just, okay. Okay, never mind. I'll just quickly shuffle through. So there's a lot of content, don't worry. Okay, so some modifications in the scheduler. So first, an overview. So first thing we realized is, and that's a link with surface metering, is our scheduler is classifying the departures, the EOBTs, and so what happens is when flights are blowing their EOBT, when they're not pushing as expected, we put these flights in the uncertain group because they are uncertain. So what happens is our system is probing these alternative routes, but it does not rely on surface metering. And so what we discovered is that when these flights would be in the uncertain group, they would be put to a later off time. And the alternative route would show earlier off time. So these showed up as falsely positive flight with candidate routes. So that's something we had to fix. And so what we did, our system is including those flights that are uncertain. So if we're to run this with surface metering, the flight that would not honor their EOBT after a threshold like 5 minutes or more would be excluded temporarily from the system. When the flight actually pushes, then now we have a better prediction of the off time, and so then the system puts that flight back in the system. So that's what this lesson is about the uncertain EOBTs. Now, delay savings. So the way we calculate delay savings, I'll go cover that initially. So we start with the undelayed times, are based on EOBTs, and essentially undelayed times are the earliest time the flight could take off with no other constraint. And so what the scheduler does is then looks at the other flights and then starts spacing the flights at the runway based on assumed rules of the spacing that is required between departures. So that essentially is what is triggering the surface delay, right? Without the scheduler kicking in, you may have, a gaggle of flights fighting for the same takeoff time, but they can't. So there's space, and that essentially what drives the surface delay. So we're following our friend here, American 1560 to Orlando. And so with just based on the surface scheduler, there's a 2-minute delay. Now comes the terminal scheduler, and so we have 2 specific schedulers. Just because of concept, we have phase 1, phase 2, TFDM with surface scheduler, and phase 3 is essentially additional capability that is compatible with TFDM. So we have a terminal scheduler that is on top of the surface scheduler, and there is a reconciliation mechanism between the terminal scheduler and the surface scheduler. But essentially, for you to remember is the terminal scheduler accounts for the miles in trail and the terminal restriction, the deconfliction of the demand across airports to the terminal fix. So we have a schedule that is built at the terminal departure between Southwest American and other airports. And then this time is passed back to the runway. And then there is a reconciliation with the surface scheduler to come up with the estimated takeoff time. So here, this is an example where you also have miles in trail to the east gate. And so our friend here to Orlando now has a 12 minutes of delay, total delay. So in this case, we're talking about surface and terminal delay combined. And so essentially, our scheduler is looking at the takeoff time of the FAL route, takeoff time, estimated takeoff time of the FAL route, estimated takeoff time of these alternative routes. And it's looking at where this flight could depart. And what simply you could say, the earliest time this flight can depart is as early as this time, right? So in this case, if this flight were to fly the southern route, it would depart at 05, which is, close enough to its original undelayed time. So our system would show, okay, there is a delay savings of about 10 minutes for this flight. between versus 12 and I think normally it should be 2. So anyway, so there is 10 minutes of delay savings there. So there are different ways to compute this. You can compare the takeoff time for both routes minus the undelayed time, or you can compare directly the 2 takeoff time, and you would end up with the same delay savings, except. So essentially, this is the complicated description of what I walked through. So what happens if you compare your takeoff time minus your undelayed time? Let's say on the first route you have 10 minutes of delay, and on the other route you have, so I'll actually use this example here. So the first file route is estimated to depart 13. Is there a tracker here? Oh. So depart at 1, and then the undelayed time was 12:45. So for this file route, there's a 15-minute delay. And so these other routes, and let's say one of the other route departs from another runway. So in this case, you know, the undelayed time is 12:55, the scheduled time is 12:55. So there is also a 0-minute delay. So if you do the difference between 15-minute delay here versus 0-minute delay, you could have, in theory, 15-minute delay savings, right? So you compare the difference between these two and these two, you make the difference between these two, you get a 15-minute delay savings. But now watch this. Now actually, the estimated takeoff time here is 12:55 versus 1300. So is there really a 15-minute delay savings? No, it's only 5 minutes. So we discovered that along the way. See, we're not that smart. So we changed this is why field tests are really useful when you actually work with real flights. So now we change our way of computing, and we compare always to the file route instead of the alternative route. I'll rephrase this. We compare the undelayed time always to the file route. So now we're comparing 12:55 to 12:45 and 1300 to there. So now we're effectively being able to say, hey, there's only 5 minutes saving between these two flights. So that's one of the lessons learned. Yes?
So what about any cascading effect from the effects you took the airplane out of? Are you capturing there's some additional placings there for other flights?
So I'm not sure I understand the question, but
Let's say I was going out eastbound
yeah,
south.
yeah,
I gave up a spot going east.
yeah,
And other airplanes maybe.
yes.
So the system is capturing that fact and moving other airplanes up, but we're not numerically capturing that we saved the one specific flight 5 minutes, but 8 other flights 2 minutes each. We're not capturing that yet. Okay. It was actually, it's interesting you say that. It was a question on my list for the panel today. We just didn't get to it. That is it something you'd like to see? And I know we've talked to Josh and Tim and other folks that seems like a more comprehensive way to capture it. So we're not there yet, but we agree.
So we have 5 more minutes. Do you agree we could maybe talk a little bit more about the global filtering?
Sure.
So this is the early mock-up of how the advisory may look like. And in Dallas, in the ZFW and the Northeast, they look at these CDRs by corner posts because they're typically used to swap aircraft. So in this case, this is a flight-by-flight basis swap. You could consider it that way. And so we plan on organizing the advisory by corner, and it would be color-coded, so the flight operators could see this, and the ATC tower could see this. This would be managed by the en route. This is our easy first step to implement this global filtering. assuming the en route will know about the playbook routes and all these restrictions. But until we can really parse those and match the CDR with those restrictions, then we're asking the user to make manual entries. But until our system gets smarter, this is what we're proposing in the near term, in the coming month. And so basically, the en route folks will be able to simply say, hey, this route is not available, this route is available, and it would show up also on the map here, where you could see, along with the restrictions, a quick bird's eye view of, which route are available or not.
Probably just to make sure, so we don't confuse anybody there. So not only that map, think of that as a situational awareness aspect of it, but what those entries would do would prevent an individual flight from showing up as a candidate, because we've said, you know what I mean, a north CDR is not available, therefore the north route is not a candidate during this particular time. So one gives you situational awareness. The other, again, in working with our airline folks, is those, and having observed them, those positions are busy. And I know I'm not telling you anything you don't know, but they're doing other things besides just looking at a toss table. And the more, I don't want to say reliable, because I think our information is reliable, but the more we present them with flights that are truly candidates that can be submitted, I think the better off all of us will be. And that's what we're learning, and that's what we're building towards. So then when they see one on the table and they begin their workload of checking with the dispatcher, checking fuel, that the likelihood is very high that that route can be flown, and if it meets what the airline needs it to meet, then they can submit and approve, and the process will go just that much faster. So.
And then just for the last few minutes, I'll leave you with food for thought. Something we're putting on the table, something we're considering of things to discuss that we could do in the future. Doesn't mean we'll do it. But here's an actual example of one of our field tests. There was a protected segment, in these playbook route advisories, typically use the playbook route to indicate some route segments that are restricted. And this is an example where a route to the north to DC, to JFK was limited, and there was a weather here that prevented from traffic to fly this way, so they had to come underneath. And so this actually impacted departures from DFW. And so here we are with the north route, and look, so now this north route is actually cutting the corner of this weather situation. And I was looking at the CRs and I was thinking, oh man, if we could only have the CR connect to this point and use, these partial route segments into account. And so it would be possible. In fact, you could take a portion of one CDR and attach it to the protected segment, and it could work. This is food for thought. So who would do that? That is an open question.
I would, for me, it'd probably be the system doing. Yeah, and I think actually Tim brought that up this morning on the panel, and I thought the CDRs here are built for weather avoidance. I think it's almost new territory to think that we'd be using CDRs to save miles, more so I think in a toss case than actually avoid weather, and it's worthy of discussion. It's just we have to build them. We have to find out what the en route facilities could accommodate, because obviously, there are certain routes and certain sectors they don't want departures in. I mean, all those kind of things. But would that make this kind of thing toss more valuable? I think it definitely would, and it would certainly produce more candidates. So, for sure.
I think we're out of time, so do you want to close this session?
Sure. I'd say thank you very much. We appreciate you coming. I hope it answered some of your questions, and again, the slides will be available in the very near future. So thank you.